All right, Algebra 2, 5.4 today. So we're going to be solving with radicals. So that radical is the house that we've been working with. Sometimes if it's nothing, it's a square. Sometimes they have a 3 for a cube root. In this example, we have a 4 for a fourth root. But we just want to get x by itself. Okay, so we're going to deal with the radical last. So let's take care of all the easy stuff here. If it helps, you could draw that line down the equal sign. It'll kind of help separate what you've already moved over and what you still need to. Um, so like right here, we have a -3. So we're obviously just going to plus 3 over. And then we have the fourth root of 9x plus 7 equals 3 here in the purple. Okay. There's nothing else outside the radical to take care of. So let's get rid of the radical. What's the opposite of the fourth root here in purple? That'd be the exponent of 4, the power of 4. So to cancel the fourth root, we're going to take the exponent of 4, but we have to do it to both sides here. So as you can see down here, the fourth root and the fourth exponent canceled. So whatever was inside is left over, that 9x plus 7. And then on your calculator, just take 3 to the power of 4, and we get 81. And now from here, it's just an algebra 1 problem. So we're trying to get x by itself. We subtract the 7, we divide by x, we have a fraction. Big whoop. Okay, it's okay to have a fraction. All right. Next example, same situation. We're trying to get x by itself. And there's a radical. So if we drew that line down the middle, we would want to move everything on the outside over. Now here's the twist. There's an x on the inside and an x on the outside. So we're still going to move over this x. So we're going to subtract x. This right side can get tricky. It's like negative x minus 11. That's how I would write it. And then don't forget about this subtraction sign in between here. Okay, that doesn't go away just because we subtracted. We subtracted here because it was like a positive x. So that positive x and the minus x cancel, still have the minus sign. Just a normal negative sign, like if there was parentheses here, it'd be like an imaginary -1. So we're going to divide by -1. We've got to do it to both sides and both numbers on the right side. So eventually these will cancel. As you can see, that went away. And then over here, a negative divided by a negative is a positive. A negative divided by a negative is a positive. So here in the purple, we have the square root. I know it's a square because there's nothing here. The square root of 9 minus x equals x plus 11. That's in the purple. Okay. Now written in black, we have the power of 2. Okay, we're going to square both sides because we want to get rid of this square root. So the exponent and the root are going to cancel. And we have 9 minus x left over. That just came from the inside of this square root. Okay. This right side gets a little crazy. We did this a while ago, probably like a month ago. We have x plus 11 squared. That's really like those two parentheses, x plus 11 times x plus 11. And then we foiled and we ended up getting x squared plus 22x plus 121. Okay. If you don't remember foiling, Google is your friend. Okay. Or go back and look in your notes. Since we have a quadratic here, this is different than the first problem where we just had a linear problem where x was by itself. We have a quadratic, which basically means we have an x squared. It's going to be easier for us to factor this to get our x by itself or to solve for x. So let's move all the junk over here on the left over to the right. We're going to minus the 9. We're going to add the x respectively to their places. So now nothing is on the left because we canceled it all out. So 0 equals x squared plus 23x, 22 plus imaginary 1. And then 121 minus 9 is 112. Okay. Again, here, Google is your friend if you can't figure out what multiplies or adds. So we're trying to figure out what adds to the middle and multiplies to the outside. 112 is a tough one. It's 16 times 7, and then 16 plus 7 is 23. That's where we get those numbers. And now we're still trying to get like what answer x is or get x by itself. That trick there, if you remember, is just flip the sign. So it's really x is -16 and -7. Okay. But since this was a quadratic, we got to check solutions. So sometimes the solutions work, sometimes they don't. So this is what checking solutions mean. We're just going to take each individual answer, plug them back into the equation, and see if the equation equals itself. Okay, so we're going to test -16 first here on the next slide. So when x equals -16, I'm going to take this -16, going back to the original problem, and plug it in here for x and here for x. Now this would be 9 minus negative 16. Okay, easy mistake there, 9 minus negative 16. So we plugged in for x here and here. That's a leave change, so the square root of 25 right here. So negative 16 minus, it ended up being 5 equals negative 11. Well, negative 16 minus 5 is negative 21, and that does not equal the right side, so this is not a solution, okay? But when we plugged in negative 7 over here, it did end up working out. So x equals negative 7 would be your solution, and this one would be extraneous, if that's how they phrase it. Last problem, pretty similar. Over here in the top left, we want to get rid of all this junk outside. So let's get rid of the minus 16 first. So we're going to add 16 to both sides. And now we have x squared minus x minus 9 to the power of 3 over 4. That's the exponent. That's the root like we talked about last week. Equals, we added this up, that's 27. This one's a little different because it's an exponential form. And so we're just going to cancel it with another exponent, but flipped upside down. So instead of 3 over 4, we're going to take it to the power of 4 over 3. And remember, you got to do it to both sides. Okay. You can actually plug this into your calculator really easy, and it ends up being 81. And then the nice part is about these exponent is that they cancel, and we just have what was inside the parentheses or the root or the radical on the left. Okay. Same as the last problem. It was an x squared. It was a quadratic. We have an x squared right here. So we want to move this 81 over to get 0 before we factor what multiplies to negative 90 and what adds to negative 1. Boom, right there, we get 10 and negative 9. Got to check our answers, of course. They both work. So our solution set would be two different answers. We would write it with a comma in between. If you have questions on this, ask your neighbor, click the help button on Savas or shoot me an email.